Earphones off, please. Finn, earphones off, please. Thank you. Right, here we go. Yesterday, I left off at exercise 2H and this example, and really this example ties in everything you needed to understand for 2H. And I've got some revision sheet on that for you to practice as well. I'm going to show you how I do this question, and you can copy it down, and it should be the same for every other one. Yeah, remember, Ryan. The most important thing that you can take out from chapter 2 is A to E. A to E is what you need to understand. G is your applications. H is what is hard. Yeah? H is what you have to really think about. So, remember yesterday I mentioned about simultaneous equations, right?
So the coordinates of the equation.
Wait, hold on a second.
Oh no, you make the y equals so.
What does it mean when we find x and y, when we solve a simultaneous equation, what are you actually doing again? Can someone remind me? Simultaneous equations. What does it mean? So remember yesterday I gave you an example. I said, let's say you had 3x plus 2y equals 7, and then 2x minus 10y equals 5. And you solve for it and you get x and y. What does that tell you? What are you finding?
The intersection of the two lines.
Fantastic. Remember, simultaneous equations, all you're doing is you're finding the point of intersection of two lines. Okay? So that means that if it's a point of intersection of two lines, two straight lines can only have three scenarios. You either have two lines with a different gradient, and they intersect once, so you get a unique solution, or you get two lines that are parallel, means that they have the same gradient. They have the same gradient, but obviously they have a different y-axis intercept. No solutions, because they never intersect. Or you have two lines that are exactly the same, hence you have infinite intersections. You intersect infinitely. Yeah, so that's why we say infinite solutions, same line, parallel lines, different gradient. Yeah, so I'm going to write here, different gradient. M1 doesn't equal to M2, different gradient. Over here, both M1 equals to M2 and C1 equals C2, so both everything in a straight line is the same. So this is the same line. Parallel lines. Different lines. That's all you have to understand for exercise 2H. In order for you to do them, that's what you need to understand, because that's what you're testing for. Yeah? So for each and every one of them, these are the things that you're trying to test for to solve them. So let's do the first one. Let's have a look. Let's look at this example here. Same concept. You got two lines here. What I did yesterday, which I got cut off by the bell, was I tried to rearrange both the equations so that I have y equals mx plus c. So that's what I'm going to do here. I want y equals mx plus c. This is what I want. This is what I have. I have m minus 2 multiplied to x plus y equals 2. At this step here, you see this looks almost similar to the y equals mx plus c. The only difference here is you have m minus 2 times x. Here you have m times x. So what I'm trying to say is your m is here. Right, but you can't have m on the same side as the y value. You're trying to move this across. Okay, so how I would do that is, if this is a positive m, to move it to the other side, you would say minus mx. So same thing here.
If it's negative, you just plug it.
Yeah. So here I'm going to say minus m minus 2x. So yeah, if I minus both sides by the same value of x's, I minus both sides by m minus 2x, I know that these two can cancel out. So yeah, as a comparison, just in case you're confused, Ryan, don't talk while I'm speaking. Yeah? Just a comparison in case that confuses you, because there's a lot of letters there. If I gave you this, if I said 3x plus y equals 2, and I asked you, how do you get rid of the 3x? What you would have told me is you would have said, well, that's a positive 3x. If you just simply said minus 3x on both sides, 3x minus 3x cancels out to be 0. True? And then you would have said y equals 2 minus 3x. Now I'm not doing anything different. I'm doing exactly the same over here. See, this is your 3. It just doesn't look like a 3, but it is a 3. Yeah? M take away 2 is a number. So that number times x, if I want to remove this, just like you did over here, if I want to remove this, I subtract 3. Because that's whatever this number is currently positive. If I subtract whatever this is, it's gone. And I subtract it over here. So the same thing here. I'm just doing the same thing. Minus 2. Yep. Okay. So from here, once I've cancelled this out, what am I left with? I've got y, see this is here, y is equal to 2 minus m minus 2 times x. This is nice because this is my gradient. I've got a negative m minus 2 gradient. That's my y-intercept. Okay, so I'm going to write here in case you sort of missed out on that. This is your y-intercept. This here is your gradient. Just like this one, you would have said the same thing with me. You would have said y-intercept, gradient. Why is this one easier? Because you have a number. A lot of us, we don't like working with letters, so I totally understand why this looks more confusing than this, but it's the same thing. I'm just calling, this is my gradient now. Okay? Next part. So I got my first equation there. I'm just going to write it in big over here. I'm just going to do a big box. You just found out y equals 2 minus bracket m minus 2 times x. That's your first equation. That's your y equals mx plus c. Yeah? What you need now is your second equation. Same concept. We're going to do exactly the same thing. mx plus 2y equals k. You want to rearrange it to get y equals mx plus c. That's what you want to do. So, I want to do the same thing. We have, up here was mx plus 2y equals to k. Yeah, let's try to rearrange this now. Same concept. I want to move all of this across. Yeah, take it away that. So that's what I'm going to do. I'm going to write in red here. I'm going to write in red. Take away mx, take away mx. mx minus mx cancels out to be 0. Okay. Fantastic. So 2y, I'm going to do in blue now. 2y is equal to k minus mx. But I don't want 2y, I want y. So I got to remove the 2. Now if that's times 2, the opposite of timesing 2 is divide. So I'm going to divide both sides by 2. So that's what I'm going to write here. I'm going to write divide 2, divide 2, divide 2. Okay, I'm dividing everything by 2. 2 divided by 2 is 1. That is why my answer is 1y is equal to k over k minus mx over 2. Or if you like to separate them, it's k over 2 minus mx over 2. So what that tells me is the gradient is negative m on 2. Y-intercept is k on 2. Yeah, so I'm going to write it underneath. Here we go. Y-intercept. Gradient. Okay? So if I put it all together, these are your two equations. You now have y equals 2 k over 2 minus m over 2 x. Okay, now we can answer the questions. Okay, so what was all this really doing? All you had to do this whole time, all this looks complicated, but all you did was just rearrange the equations. That's all I did. I just rearranged it so I get y equals mx plus c. Now we answer the question. They say what values of m and k such that the system has no solutions. So you go back to your understanding of what I taught you over here. The only time you have no solutions, or where two lines don't intersect, is which one? Parallel. Parallel. So for parallel, you just have to have the same gradient. But you also have to make sure the y-intercepts don't equal to each other. Yeah? So now you look at these two equations. All you have to make sure is the gradients equal and the y-intercepts don't. Okay, that's all you're doing. So you're equating these two. You're saying this is m1, or gradient 1. This is gradient 2. So the first thing you said is gradients have to be the same and y-intercepts have to be different. So I'm going to write it down. So gradients have to be the same, right? Minus m over 2, that's the gradient of g2. It has to equal to gradient of 1, because that's what you said here. m1 equals m2. This is the gradient. This is the gradient.
How do you know if they're parallel lines?
If their gradients are the same, then it's parallel.
So you check it now.
So you're making it equal because you want no solutions. Because the question says you want no solutions. So you just told me it must be parallel. For it to be parallel, that means these two gradients have to be the same. So that's what I'm going to say. I'm going to say, all right, negative m over 2 must be the same as this gradient, which is minus m minus 2. See what I'm doing there? Okay, so I'm just following that same pattern that you said. Parallel, okay, this is parallel. Two gradients are the same. So now, I solve for it. So I've got this equation here, expand both sides. This gives you negative m plus 2. You have negative m over 2 here. Now you want to solve for m. I know we don't like fractions. How do we get rid of this division? Times. So that's what I'm going to do. I'm going to write over here, times 2, because that's division of 2. So times 2 to both sides. If you times this by 2, they cancel out to be 1. 2 divided by 2 is 1. So now I have negative m is equal to 2 times negative m gives you negative 2m. 2 times 2 plus 4. I'm almost able to solve m now. Okay, so what I would do here, I try to collect all the m's together. And I can say, well, since that's minus 2m, if I want to remove that, I can say plus 2m. Plus 2m. Negative 2m plus 2m cancels out.
So 4.
4 equals 2. What's 2m minus m? M. You got m equals 4. But you haven't answered the question yet. You just found out m. What about k? See, m, you told me that the gradients have to be the same, but not only that, for it to be parallel, you had to make sure the y-intercepts don't equal to each other. Okay, so if you were to do this one now, y-intercept is currently 2, and that's k on 2. So the question is, if the y-intercepts can't be the same, so currently the y-intercept is k over 2, and we don't want that to equal to 2, because that's the y-intercept, what can't k be? 4. Because 4 divided by 2, see k cannot be 4. Because if k equals 4, 4 divided by 2 gives you 2. So to answer the question appropriately, you have to say m equals 4, k cannot equal to 4. And that's for the first part. See what I've been doing? Yeah? And then if you want to do the next few, you want to do infinitely many solutions. It means, see, for infinitely many solutions, this is easy. Infinitely many solutions, you already know that you need the same gradient, same y-intercept. You already found the gradient, which is 4. So to answer B was easy because you already found that you did all the hard work already. Now you just answer the question. Gradient has to be the same, so 4, and k has to be 4 because then you get both y-intercept and gradient the same. Yeah? Whereas unique solution, what do you have to make sure to have a unique solution? Y-intercept doesn't matter. What's the most important part here? Gradient needs to not be the same. That's the only thing. Yeah, because you can have 3x and 2x. Doesn't matter if they both cross the same point for the y-axis intercept. The only part that you got to make sure is the gradients are different. Because if they have different gradients, they're not parallel. If they're not parallel, for sure they're going to cross each other. They're going to intersect. That's the only point that you want. For one unique solution, the only way for two lines to cross is you have different gradients. That's all that matters. Doesn't matter about the y-intercept. Okay? So in this case here, as long m doesn't equal to 4, we're good. Because that's the only time where they're going to have the same gradients. Therefore, as long as m doesn't equal to 4, I will not have any parallels, no infinite lines. Therefore, it has to be unique. Okay, so you see, what was the hardest work? It wasn't B, it wasn't C, it was A. A was the hardest work because you did all this algebra and it's here. See, that very step here, that was the hardest step. And what was I teaching there? I was just doing exactly these 3 things I taught you here. You get 3 scenarios. Unique solution, no solution for parallels, infinitely many. And I'm telling you, this is what you're going to be doing in Spec, and you'll be doing this in next year's for matrices as well, and it'll be the same concept. Okay, so if you understand what I'm saying today, you'll be carrying on to next year as well. Okay?
Infinite solutions. What's the solution?
Infinite solution means it has to be the same line. So if it's the same line,
Solution on the way?
No. So same line means that they have the same gradient and same intercept. So for example, y equals 3x plus 1. Yeah. And that's all you have to do. So answering the question... Sorry?
Which intercept do you put down? If which one do you choose?
You don't choose one.
So you just put y equals...
No, I just answered that for you. Well, I don't know if you were listening. You watch this video again, okay?
What do you mean?
Watch the video again, because I literally just explained that. No. Parallel lines was this one.
Yeah.
See, parallel lines, I explained just now. I said the gradients have to be the same. That's what you told me, and then you zoomed out, right? Oh, you did. So right here, we solved for m. I got up to this point. I said, if m is 4, gradients are the same. Now, if gradients are the same, they could be parallel. True?
They could. So they could be or
They could be. Because what does it mean to be parallel? I showed you over here before. Remember, I read this? What did I write here? I wrote, gradients the same, y-intercept's different. See, I literally wrote this. Now, I don't know if you're writing my notes.
So it is parallel because y is not equal to 4.
But I have to make sure this is different. See, that's what I did in the next step if you were watching. See, in the next step I said, okay, now if m equals 4, they have the same gradients. Now to make sure that they have different intercepts, I showed you here. I said, this is the y-intercept, this is the y-intercept. No, they're not different yet. Because it depends on what k is. So I did it over here. I said, if k over 2 needs to equal to 2, I asked you guys just now, I literally asked, I said, what would k have to be to make these two the same? So that's why when k equals 4, these two are the same. But I don't want them to be the same. No, I'm just saying, so when k is 4, because your job is to find out m and k. You know what? I'm going to explain it individually with you, okay? Because I explained it in this video, and everyone was listening on this part here.
Clearly listening.
Yeah? Well, then I'll explain to you individually again. Yeah? I'll explain to you individually, because I know what you're complaining about. You're thinking of one number, but it's not. Yeah? But I'm recording this right now. People who are watching this are going to be like, but I got it already. Okay? So I'm going to explain it to you individually. And I want you to write my notes. Okay? Because you weren't writing my notes, so while you're saying this, I'm repeating myself again. Every arrow that I'm doing right now, I already wrote, I already explained it. Yeah? So I need you to write my notes. You can't just sit there and say that you got it all if you're not copying anything. Okay, good. Well, I want you to copy it down then, so that when I refer to it, at least it means something. Now you're just doing it on your memory. Yeah?
So the method is you just have to rearrange the equation.